In this video, I'm gonna show you dynamic memory allocation in C, as well as structs, which kinda go along well with this topic. So let's start off. Open up a file. Well, actually, let me split this terminal. And open up a file, main.c. As usual, include standard io.h and define main argc argv and return 0 for everything went well. Now, in the last video we talked about static memory, and static memory is, well, as it says on the tin pretty much, it's different from dynamic memory. Whenever a program runs, it creates what's called a stack. And a stack is a static piece of memory that's allocated exactly for your program. So say I define an integer test and a character array of 50 characters. The data part of the stack, there's more stuff stored in the stack besides the data, but the data part would be 54 bytes long, because every character is 1 byte and every integer is 4 bytes. This cannot be extended, nor can it be contracted. However, the operating system also creates a place in memory called the heap, which is a significantly more complicated process than the stack, but it allows for dynamic memory, i.e. we can define a variable, or rather a pointer to a place in the heap at which a certain amount of data is stored. We can then extend that allocated space whenever we want. Alternatively, we can contract that space as well. The main difference is that the memory in the heap is not all contiguous. While in the stack, if we have an array, every character follows each other. So these 50 characters would all be one behind another. In the heap, that isn't necessarily the case. An array might be fragmented over completely different memory addresses in the heap, and we wouldn't even notice because the kernel takes care of all of it. Alright, so let's start with the practical aspect of this video. The function we're going to look at is malloc. And in the Linux programmer's manual it says that malloc, free, calloc, and realloc all allocate in free dynamic memory. And they're included in standard lib.h. So before we do anything else, let's include that library. Standard lib.h. Now, the functions we're interested in are as follows. Malloc, which will allocate a certain amount of memory in bytes. Free, which will free up the memory after we're done with it. And realloc, which will either extend or contract the amount of memory we have allocated. Very simple. So you can see in the description that the malloc function allocates size bytes and returns a pointer to the allocated memory. The memory is not initialized, meaning it's just all zeros. Alright, let's begin. And at this point I want to introduce structs as well. Now, a struct is a very simple concept, much like a JavaScript object, except more low level. And structs can be defined in two ways, but the way I do it, and the way that's commonplace nowadays, is via type def. Type def struct braces like so, and in here we will type in the name of the struct. Now, in this video I will show you how to create essentially a dynamic array of structs, and it will act like a stock data in a shop, right? So every struct will be an item. So let's say call it item, and an item will have a name, so that will be a character array, and this will be fixed at 50 characters max, and we'll have an integer value, which is the value of the item in the shop, essentially. And you get it. So a struct consists of variables, and those variables can then be accessed for every struct instance. It is also commonplace for type defs to put a T after the name of your type, like so. So you know it's a type. Because what we essentially did here was we defined a custom variable type. We can now have an item T, and we can call this item, and now we have a variable of type item T. So that's a struct. Now let's begin the actual memory allocation part. We'll do this in the form of an interactive application. We'll define an infinite while loop, like so. Besides this item T, we will also define a pointer to an item T, and we're gonna call this stock. So we can then allocate memory and have this pointer point to that memory. So let's begin. We'll begin by allocating the memory for one item. However, we want to do that whenever we add one item to the stock. So this while loop will allow us to add however many items we want, and we always want there to be enough memory for those items. As such, we want something of an iterator variable, for example I, and we also want a variable that will track the number of items that we actually have, like so. We will initialize I at 0. We will initialize number items at 1. From here, we will make a call to Malloc, where we will set stock to the return value of Malloc, which is a pointer to the allocated memory. Then the size, where we can use a built-in C function called sizeOf, which will get whatever the size of the arguments is in bytes. So we can do sizeOf item T, and this will get the size of item T in bytes. And this doesn't slow down runtime. This is compiled into a number at compile time, so speed is preserved. Now we have a stock, and it's a pointer to a memory address, which is just big enough to fit in one item. From here we can use in a built-in C function, or a function that was included in standard io.h, scanf, which is pretty much the opposite of printf. We'll create a prompt with printf, where we'll prompt for the name of the item, and scanf will allow us to scan the name of the input of the user into a variable. So we want to input the type of input that we're gonna be inputting, I guess, and then the place where we want it to be stored. So that will be item dot name. So we use dot syntax, just like in JavaScript. Here we can copy these two lines and change this to value and this to D. And as we learned from pointers, when we're referencing something that isn't a pointer, we need a reference like this, so it actually alters the actual variable and not a copy of it. Now we have name and value, and it's stored in item. From here it's extremely simple. All we have to do is add that item into stock. So we will do stock I equals item. From here we can increment I, and we can also increment number items. But before we do that, we want to reallocate the amount of memory we have so that we can fit in one more item the next iteration of the loop. So this is where realloc comes in, and realloc takes in the pointer that we're going to be changing the size of, and the size that we're going to change it to. So the pointer is stock and the size is number items plus 1, like so. And now we should have a mechanism for adding items into the memory in the heap. The last thing we want to do is free our pointer after it's done. This will uninitialize the memory or set it all to 0, so that whenever we want to allocate more memory on the heap, we can be sure that it's going to be all zeros and all clear. But now, well, let's just check if this compiles first. gcc main.c-o main and run main. And now we can do test 1 and 10, test 2, 20. So it seems to be working fine. The warning up here is that we didn't use the return of realloc. And let's check out what realloc returns. So realloc, if pointer is null, then the call is equivalent to malloc size. For all values of size, if size is equal to 0 and the pointer is not null, then the call is equivalent unless pointer is pointed to is moved, a free pointer is done. So essentially what we can do if the call to realloc return the 0, which we can do like this, if not, this is the not operator in C. If not realloc, so if this returns null or 0, we want to turn 1 and put the braces around this. And we'll use a function called fprintf, which isn't necessary, and this means file printf. Why file? Because everything in Unix is a file. We can print to standard error, unable to extend memory. Like so. So now this will give us some error handling and hopefully remove the error. There it is. Test 1 value, test 2 value. Finally, and this isn't anything to do with dynamic memory, but we will print out the items in the stock just so we can be sure that's actually adding the items. So I guess after the call to putting the item into the stock, we can print f, or with a for loop rather, where we'll define an iterator for the for loop, which will be j, because I is already taken. For j is equal to 0, j is less than I, put this after I, because it's the only way it will work, because when I is increment, then we want it to be less than I. J++. So what this will do, this for loop, if you don't know, it will iterate for as long as j is equal to I, so essentially it will iterate the same amount of times as there are elements in the stock pointer array. And then we can printf item d name is s, value is d. That's a big format string, and now we can do item j plus 1, because we want to start at 1, not at 0. It's just a cosmetic thing, really. And the name is gonna be stock j.name, and value is stock j.value, like this. Test 1 50, and it works, but let's just clean up the output. We don't need a space after this new line, and it would also be nice to add in a new line at the start and a double new line at the end, so it's separated from the rest. Now we have name test 1, value 10, name test 2, value 70. And that is our item storage. And instead of putting a new line after each, we'll just printf one new line after this. Test 1, test 2, like this, and we have a fully dynamic item storage array that will extend no matter how many inputs we put into it. And you can see the wide variety of uses that this can have for, say, game inventories, or if you're creating some kind of database system, some kind of user system where you put in everything into a array and then you write that all to a file after. A lot of uses. That's dynamic memory allocation. I hope you learned something. I also encourage you to play around with these various functions, including calloc and realloc array, which we haven't covered. Read the manual and have fun programming in C.